Our next topic is non-linear regression. First point, fitting of second degree parabola. Let open bracket xi comma yi, where I is equal to 1 to up to n, be n pairs of values for bivariate data on the variable open bracket capital X comma capital Y. Then let capital Y is equal to a plus bx plus cx square, equation number 1, be the second degree parabola of best fit for the set of n points where a, b and c are the constants to be determined by using the principles of least squares. Then for given value of independent variable capital X is equal to small x, the regression estimate of y denoted by y cap and is given by yi cap is equal to a plus bxi plus c into xi square. Error in estimation denoted by small ei is given by ei is equal to yi minus yi cap, which is also equal to yi minus value of yi cap is a plus bxi plus cxi square. So multiply this minus sign in this value of bracket. So yi minus a minus bxi minus cxi square. Then let we know that s is equal to summation of ei square, which is equal to summation in bracket value of ei is yi minus yi cap. So summation in bracket yi minus y cap of bracket square, which is equal to summation, then value of y cap is yi minus value of y cap is a plus bxi plus cxi square. So yi minus a minus bxi minus cxi square bracket square. Using principle of least squares, we have to determine the constants a, b and c so that capital S is minimum. Now S is minimum if dabba S upon dabba A is equal to dabba S upon dabba B is equal to dabba S upon C is equal to 0. That is partial derivative with respect to partial derivative of S with respect to A, B and C is equal to 0. Then now first consider dabba S by dabba A, that is differentiate S with respect to A, which is equal to dabba A upon dabba A in bracket summation in bracket yi minus A minus bxi minus cxi square whole bracket square is equal to 0, which gives, then differentiate this term with respect to A, which gives summation 2 into yi minus A minus bxi minus cxi bracket xi square in bracket and differentiation of this A is minus 1, differentiation of this minus A is minus 1, which is equal to 0. Then dividing by this term minus 2 and simplifying, we get summation yi is equal to ni plus b summation xi plus c summation xi square, and denote this equation 2. That is divide this term by minus 2 and apply this summation in bracket and then separate the term, we get this term. Then next differentiate dabba S with respect to B is equal to 0 is dabba by dabba B open bracket close bracket summation open bracket yi minus A minus bxi minus cxi square whole bracket square open close bracket complete is equal to 0. That is differentiation of this term is summation 2 into yi minus A minus bxi minus cxi square bracket complete, and differentiation of this b minus bxi is minus xi is equal to 0. Also divide this term by minus 2 and simplifying, we get summation xi yi is equal to A into summation xi plus b into summation xi square plus c into summation xi cube. This is denoted as equation number 3. Then also in next step differentiate S with respect to S is equal to dabba by dabba C in bracket summation yi minus A minus bxi minus cxi square bracket square is equal to 0. After differentiating this term with respect to c, we get summation 2 in bracket yi minus a minus b xi minus c xi square bracket complete, and differentiation of this c xi square is minus c xi square is equal to 0. Then dividing this term by minus 2 and simplifying, we get summation xi square yi is equal to a into summation xi square plus b summation xi cube plus c summation xi raised to 4. This is equation number 4. Then in next step, the equations 2, 3 and 4 are known as the normal equations for estimating a, b and c. Then knowing the values of xi, yi, I running from 1 to n, we can calculate summation xi, summation yi, summation xi square, summation xi yi, summation xi cube and summation xi raised to 4 and summation xi square yi. If we substitute these values in normal equations, we get 3 equations in 3 unknowns a, b and c. Then so solving them simultaneously, we get values of a, b, c. Substituting them in 1, we get second degree regression curve of y on x. Write the stepwise procedure of fitting the curve y is equal to a plus bx plus cx square using method of least squares. Then first step is let y is equal to a plus bx plus cx square. This is equation number 1. The normal equations for estimating a, b, c by the method of least squares are summation y is equal to na, summation y is equal to this, summation xy is equal to this and summation x square y is equal to this. This is equation number 2, 3 and 4. Then step second is for n pairs of ordered pair xi yi on 2 variables capital X and y, find summation xi yi, summation xi comma summation yi, summation xi square, summation xi cube, summation xi raised to 4, summation xi yi, summation xi square yi. And step 3 is substitute values of sums in equation 2, 3 and 4. That is, substitute this summation value in this equation and simultaneously to get values of a, b, c. And step 4 is substitute values of a, b, c in equation number 1. Then we get required equation.